It is, of course, climate tipping points that I'm talking about tonight. The image on the left are increasingly eroded farmland here in the UK. The image on the right, a surcharging sewer. We were told until recently that our sewer surcharges were related to climate change. A picture is becoming more apparent now that it's perhaps lack of sewer capacity. Let's be generous and say it's a combination of both. Certainly there's been an intensification of rainfall that I've seen. Let's dig into some of these issues. First of all, I think James has given you a pretty good introduction in terms of what we do at Water21. It's not just me. There's always been a handful of us older professional engineers working with and mentoring students to complete community-led projects. We're able to be innovative because we work outside the policy process framework that's laid down by the government, because we work on intergenerational knowledge. This was built as being based around my experiences in the Stroud Valleys. The Stroud Valleys has been my home since I was 9 years old. I have a passionate interest in the water environment. I used to be a keen fisherman. Sad to say, it's not really worth fishing these days. I thought I was going to restore salmon to the local rivers. I failed completely. But suffice to say, we've been able to originate a lot of innovation, and I hope we're still doing so. Nature-based solutions, which are going to be a recurring theme through this talk, are now widely accepted as the way forward. There are some problems with their implementation. You can see our version of nature-based solutions in 1993 on the right-hand side. We include even hydropower in there. That's not something that's presently particularly included in nature-based solutions by the wider academic world. Our view in 93 and still today is that the water that drives hydropower, as also the wind that drives wind power, is a gift of nature. And it's a case of working with nature's bounty across all these nature-based solutions to get the full benefit. So in terms of amplification of climate change, we're all well aware of what's going on. Just a few examples here. Toddbrook Reservoir, which was declared a danger of life because it was at risk of collapsing, because it was overtopping in an intense storm in August 2019. Even more dramatically, in 2021, the shocking, really shocking floods in Germany and all across Europe at that time. Over 200 people died, 196 of them in Germany. And we are seeing intensified rain, drought, and temperatures. We're going to look at some of the reasons for that tonight. We're also going to look at the resolution of these extremes. Here we're looking at Whiteadder Reservoir up in the Scottish border region, one of many hundreds of earth and clay banked reservoirs like Toddbrook across the UK. And the Toddbrook episode has caused a serious rethink in terms of how such sudden inundations be dealt with. And just to show you one of our latest current projects, an innovative, in fact, so innovative, we believe it's the first of its type solution, a siphonic penstock. Nothing too novel about that, except that we're also featuring a hydro turbine on the bottom of it to make use of the normal overspill that's available at this site. So thank you to Scottish Water, specifically to Scottish Water Horizons, who've worked very hard over the last 18 months to get this off the drawing board, and I'm pleased to say we've just started work on the turbine. We represent Osberger, as James explained. They're one of Europe's premier manufacturers of hydro turbines. We can see here detailed the penstock, the turbine, and the storm bypass. So an 800mm diameter bypass pipe for really very quick drain down if required. I was a keen fisherman. You may wonder why on earth I'm promoting hydro turbines. Surely they're bad for fish. Well, certainly big hydro is catastrophic for fish. It totally disrupts fish passage and migration. But quite counterintuitively, small hydro is one of the best things on a river for fish for a whole load of reasons. Turbines, just like fish, need clean water and plenty of it. In the case of the Osberger turbine, which was a British Empire patent in 1920, you can see it's like an enclosed water wheel in the casing there. It has this air intake valve. So it dramatically aerates the water throughput. And as you can see down on the lower left-hand corner, one of our student studies measuring that biodiversity gain against the three main types of run-of-river turbines. We supply all three. They all have a place in terms of power generation, but the crossflow is head and shoulders the best for biodiversity gain, for the simple reason that it breaks up all the suspended solids that carry the unregulated toxins that are the real cause of fishery decline. And incidentally, these two featured turbines are in sewage infrastructure. So it's a self-cleansing runner. This means that you can fit a turbine anywhere after primary treatment. Particulate sizes of 10mm and below can be taken into the turbine with no problem at all, and at other locations on water company infrastructure as well. So a 770 kilowatt turbine on the left, and I think it's 117 on the right. Cleverly disguised as a pile of logs, as you can see. Cleaning rivers is something that certainly Georges Monbiot would like to see done. He put out a live show Riverside in 2021 from the Wye Valley, looking at the shocking decline in river water quality. Most of this is from farm runoff, but a significant amount from sewage as well. Monbiot has other partners in trying to bring pressure to bear on improving river water quality. Virgil Sharkey is perhaps the most blunt, I suppose, is the word I'm looking for in his statements. Paul Whitehouse has a series on BBC TV at the moment. Groups like Windrush Against Sewage Pollution really spelling it out in very hard-hitting terms about the state of our rivers, and I think driving a general public disgust with the sewage pollution, certainly, which of course is pathogenic, and also the farm waste. There's been quite a lot of effort put into nature-based solutions to help watercourses, and of course, these are to be welcomed generally. Yeah, putting meanders back into our rivers is important. Certainly our lowland UK rivers were heavily modified centuries ago, mainly for water power, but also boat traffic. We need to remember, however, that most of the impoundments, and certainly those in Stroud, where I'm based, have been in place for certainly a century or two, if not more. And up until very recently, migratory fish, eels and salmonids, had no problem getting through those impoundments. So when we see headlines like how this water channel is helping nature thrive, actually we need to take it with a pinch of salt, because we're welcoming fish into rivers where the conditions are so toxic that they're not going to thrive at all. And some of these structures are just pointless. I mean, the one on the left, 300,000-pound fish baths, to bypass a low weir that was no obstacle to fish passage. The one on the right, I don't know the cost of that one, but comparable probably to the other, was bypassing a mill where the sluice gates had been taken out. So the fish could actually get right through the mill. We really don't have the sort of money in the public purse to throw it around like this. There are better uses of this money, probably in helping farmers get away from the really toxic practices that they've been encouraged to use. I mean, they've done what they were told. They were told that these chemicals were harmless. Virtually all nitrate sensitive areas in the UK have failed. So even the planning to reduce these negative effects is ineffective. So the whole culture of agriculture has gone down a very dark alleyway and needs huge change. As a student of agriculture, I can tell you that actually these problems date back hundreds of years, probably to the enclosures and clearances. You simply can't safely mechanize and automate the production of food. It needs people, and we need people. People need meaningful lives and work doing this. We'll come back to this a bit later in the presentation. Turns out that this cheap food actually isn't even cheap. Some great work by the Sustainable Food Trust, taken forward now in a great book from Routledge, looking at the true cost of our food. And it turns out that a 3 or probably now 4 pound chicken in your supermarket comes to you at huge environmental cost. And that image you saw on the previous slide was chicken manure being spread on fields, which then in turn pollutes rivers and aquifers. The work for the people, quite apart from the animal husbandry associated with these farms, is really appalling. There's huge use of antibiotics in this intensive production of meat across all animal types. And we just shouldn't tolerate this sort of cruelty, apart from anything else, in our society. One of our studies in 2010, looking at the effects of this intensive chemical farming, a lot of the foodstuffs for these intensively housed animals are produced as grains. And on our Cotswold brash soils, which used to be free draining, but with a fairly shallow layer of topsoil, the damage is all too clear to be seen. I couldn't believe the findings of this study in 2010. Erosion rates, this is as a universal soil loss equation. So what we're plotting here is the risk, the actual risk of soil erosion, which has since only turned out to be too true, of 60 tons a hectare per year, at a value, a nutrient value as a replacement for fertilizer in 2010 of £100 a ton. That now equates with the increase in fertilizer cost to around £400 a ton. Quite extraordinary. And so this degradation of soil, compaction, loss of soil porosity, caused through the use of agrochemicals is certainly, from my ground level view and that of our students, the biggest cause of flood and drought. And it won't be any different through not only much of the UK, but much of Europe. And yet it never seems to feature in the mainstream reporting on these issues. So let's take a look at 2 farms in Stroud, both according to the Cranfield Soilscapes data on free draining Cotswold brash, Farm A and Farm B. My 3-year-old daughter helping me, as you can see, to analyze what's going on. So Farm A, a chemically farmed area of land. There in the center is a field of Cotswold brash under cereal cultivation on a February day after light rain. And as you can see, the water is just lying on the surface. This is no longer free draining, it's impervious. Now, that area had been increasingly used for low-till glyphosate farming. So with glyphosate, there's a double application. Just before harvest, the crop is sprayed. And then after the harvest, that is when they then blitz the field again with glyphosate to prepare it for the next crop and kill all the weeds. On the top right, you can see a hydraulic ram pump. It just happens that I maintained that ram pump for over 30 years. And with the use of glyphosate, I immediately saw the results. Those are my feet standing in several inches of topsoil that have issued from the spring. We have a very complex hydrology in Stroud. In some areas, it's taken 50 years for the transport of these silts to come down through the clay rock horizons. But in the case of this catchment, a small sub-catchment, totally detached from the main Cotswold aquifer, so not affected by water company abstraction at all, but consistently the flows from these ram pumps, or the flows feeding the ram pumps, and in turn the performance of these ram pumps has just got lower and lower each year. This would be called climate change. I beg to differ. So the other really sad thing about this is that this is not only highly exploitative and highly polluting, it's not really doing the farmer any good either, because he's not making much money out of it. So huge change required in our farming. And it's not just the arable farming. You can see a gammarous shrimp down there at the bottom of the screen. They have largely disappeared from our local streams. Of course, they were an important foodstuff for eels and trout. The eels are much scarcer than they were. The trout are still there, but much smaller, no longer pink-fleshed, now white-fleshed, and so on. One of our student studies looking at various types of river silt. The darker the silt, generally the more manure in it. In terms of pasture management, we have serious problems there as well. The wormers or anthelmintics that farmers use, over-the-counter medications that they can just buy freely. These pass right through the animal. And so cowpats, for example, no longer degrade in the same way that they used to. They just sit and set hard in the sun. They no longer have bugs in them for the badgers to pick over and spread the manure over the pasture. And when it rains, this manure carrying the anthelmintic residues just runs into the river. So much for conventional chemical farming. Here's a man, Jake Freestone, who I've met a few times, between Cheltenham and Tewkesbury. He manages a large estate, and he is converting now from glyphosate based farming. He believed the marketing hype that this was good for the environment. I mean, it wouldn't. If you want to check out a bit more about glyphosate, just Google the Monsanto papers and you'll be shocked. But that's just looking at human health. But Jake found in this shocking summer that was just gone, 2022, a 10 centigrade temperature difference between those fields where he's still using normal chemical farming and those where he's reverting back to more traditional farming methods. So when you consider that probably 90% of arable farming in the UK and the rest of Europe has gone through this temperature change through these farming methods, you can see now, and it's not controversial to say this, the amplification of climate change is really coming about. There are other factors as well, of course, and when we get a fixed high pressure system over Europe, temperatures are going to get unbearably high. Not a lot that civil engineers can do about this. You're doing your best to deal with the effects. There are measures in the landscape that can be done in addition to going back to traditional farming. Incredibly, as an irrigation man, I can tell you that just storing stormwater and irrigating with it can double food productivity. So there are really very simple solutions. We were working on a flood attenuation scheme. I think James told you we did some of the first modeling work on upstream attenuation. Our poor student from Italy said I was mad for the first month of her time. She came from the University of Trento, where at that time, 2008, she was taught floodwater had to be got rid of downstream, and all the software and everything was geared around that. But after a month, she got it, and she laid out the criteria for upstream attenuation modeling. Many others have taken that much further forward, and this is an important job for civil engineers. During that study, we approached the farmers in a 14 square kilometre catchment that we were working, and almost without fail, 90% of the farmers welcomed the opportunity to have some stormwater attenuation. They could make use of it. One dairy farmer, I said, would he have a stormwater lake to help protect the people downstream? And then he'd have some water to irrigate his pastures during dry spells. His answer was very wise. He said, yeah, of course I would want it. But he then went on to say that they won't allow it. That may be a follow-up in the Q&A, but moving quickly on. The intensification of convective storms is easily understood. These are driven by warm air and moisture. A catastrophic storm event in Germany was in a region surrounded by chemical agriculture, here and at many other locations around the world. Let's carry on our little farm tour in Stroud. We're going now to Farm B. I don't want to leave you depressed that we're not going to be able to feed the world. We can feed the world, but it requires extreme care and diligence to farm without chemicals. It's a real calling. And there are people who want to do this. And it's more akin to gardening. And it's best practice at a small scale. The productivity of an allotment is orders of magnitude per square meter than a large-scale farm. So that really is how food should be produced. And this is really taking us way back to 250 years ago, before the enclosures, letting people back on the land. We can't convert to organic overnight. They tried that in Sri Lanka, and it was a catastrophe. It takes at least 10 years to make the conversion. You need to stack enterprises. You need on the land. You need to create a symbiosis between all the practices. Animals have an important role. There are vegan methods of doing this. There are a few vegan practitioners of effectively zero input farming. And other than trace minerals, which have been washed out of the soil, which can be recovered from seaweed, for example, or volcanic rock dust, that zero input really forces best practice. And as I say, if you store the rainwater, that productivity can be boosted. And my little daughter, they're very happy at the handfuls of rich, absorptive soil on this farm after just 20 years of compost applications. The French government at Paris COP proposed a very elegant solution to the world's emissions. I think a very rough calculation on their part was that just 0.4% of return of carbon to the world's farmland per year could account for all the world's emissions. Well, it would put a lot of chemical companies out of business very quickly, and certainly academia had been looking in a different direction. This paper here, which I reference, and the link for all of these references will be in the PDF circulated after this event. Yeah, they roundly criticized this French proposal. But if you dig into that paper, you'll see there's just one reference to compost application. And surprise, surprise, it didn't return 0.4. No, it actually returned 36. That's nearly 4% soil carbon a year. So yeah, it can be done. But it requires a huge cultural change. And that's not going to happen overnight. It can be done even in the center of the Sahara. So that storage of rainwater, this is in Darfur, an annual rainfall of less than 300 millimeters, but that is sufficient by impounding inline impoundments. We couldn't do this in the UK, but we can make offline impoundments, which have the same benefit. Just by trapping that water, storing it in the catchment, getting it out on the fields, those fields brown because they're sequestrating carbon on the air, atmospheric CO2. I've already mentioned the appalling effects of anthelmintics. Incredibly, this one, ivermectin, is a fermentation product of a soil bacteria, which normally is part of the soil microbiology that sequestrates carbon out of the air. And we put it back onto the land, and it's no coincidence that fisheries have collapsed coincident with its use. And surprisingly, the Eels Directive makes no mention of this. It looks at other solutions to restoration of eels. So another one of our students, Dr. Adam Broadhead, as he now is, he was working on our program to try and resolve flooding with upstream attenuation. And he wrote a great paper, again, which you can read, the link is there, working with the various flood action groups around Stroud. They all had different ideas on how to fix flooding, but at the end of the day, it just comes down to science, empirical science. Many of you watching tonight will be aware of working with hydrographs to determine flood control, typically 20 descriptors: soil type, landform, local rainfall, etc., channel capacity. These are the empirical criteria, of course, which any flood engineer works with. And the good news is we can change those criteria. So at the moment, the soil data, I would say, on most flood planning is hopelessly out of date, but we can improve that soil data. We can plant forests, we can put ponds in, reservoirs, etc. So actually, we don't need political oversight of this. We just need honest engineering based on neutral and unbiased numbers. We're not there yet. What are those neutral and unbiased numbers? Well, they relate to critical risks, temperatures, we've already talked about, public health, we're going to talk a bit more about that in a minute, emissions, sequestrations, flood frequency, changing the hydrograph, retaining water in the land to moderate oceanic rises, biodiversity loss, biodiversity gain. And there is some urgency. We've got a couple of media reports on the right-hand side. Chief scientist Patrick Vallant saying it's going to take 100 years to fix climate change. Well, I could use a few choice agricultural terms at this point, but I'll refrain from doing so. We don't need to spend 100 years. We probably need to spend 10 years, and we need to get started very quickly. These are, of course, critical risks. First and foremost, public health. We're going to look at that shortly in a bit of detail. And we're greatly assisted just put down at the bottom by the 5 new DEFRA principles. Principles that we should have always applied to our land and water management. You know, the polluter pays, rectification at source, use the precautionary principle, integration, prevention. Interesting to see how this might, for example, be applied to the charging for storm overflows. You get my drift, I'm sure. So we've been told in the last few years that we shouldn't swim in rivers. Well, there's various wild swimming clubs across the UK who seem to be almost actively encouraged in what we now know to be a foolhardy pursuit. I'm sure we're very disappointed by this. I just popped down there a notice on a drinking water fountain in Gloucester that I passed the other day. You know, we have a water industry to protect public health. It's actually the front line of public health. The health gains brought about through Bazalgette and others, sewer engineering, comprises, along with refrigeration, better nutrition, empirically, and this isn't a matter of opinion, this is an empirical fact, comprises 90% or more of the human health gains in the last century and a half. So I'm not anti-sewers any more than I'm anti-antibiotics or vaccines. All 3 of these are remarkable technologies. Certainly in the case of sewers, well, they're just not regulated to any sort of public health criteria. And my concern, dating from my days being the king of the muck spreaders in the UK with Bauer, we were spraying pathogens into the air with our muck spreading equipment, and then the realization that every time it rained and the sewers overflowed into our rivers, weirs were spraying fecal particulates over adjacent communities. Took a step forward only in the last week with the publishing of data confirming this. California, I think it was, fecal pathogens blowing inland just from the spray from the waves at sea. This has been known about, of course, for a long time. You're not a competent sewage engineer if you don't understand risk from fecal particulates, and you're not much of an engineer if you don't understand that a weir generates a spray during flood or spate conditions. I'll leave it at that. There's a paper you can look at. It's a 2006 paper. Some images there from Stroud. This image here actually is seagulls feeding on feces as they come up in a field in front of the local environmental health officers. I actually had an involvement in this because Severn Trent were very good at the time of privatization. They totally, and I've worked on and off with them closely through the years. They agreed to absolutely not let any pathogenic material into the watercourses. And so it was let go of in the field in front of the council office, who at that time were simply loading more and more housing onto the sewer network. The image lower right is the current situation. Anyway, I better move on. Time is probably running out. So we demonstrated SUDS, our small team, first of all in 1991. We were seeking to demonstrate a system of hydraulic competence, a resolved system where there could be no real chance of any fecal contamination of the environment. Resilience is a word that I take exception to. Resilience to me is just kicking the can down the lane. So we were trying to demonstrate the methodology and the methods within that methodology. For wastewater treatment, we incorporated aeration, rainwater harvesting off the roof, storage of that water, and also irrigation, which isn't really featured in SUDS these days. And I suppose as a cautionary tale to those who think they've got a bright idea and want to get involved in municipal engineering, to my utter horror, within just 18 months of setting up Kirsty McColl's reed bed, it had clogged solid with sediment. So, yeah, I was distraught at the thought that I had gone on primetime TV to promote this very short-lived method. There were reasons why, which I quite quickly came to understand. By powerfully aerating it, I was driving this sedimentation and some sequestration, it must be said. And I also came to realize that the gravel reed bed method was profoundly flawed. But SUDS as a methodology has taken off. It's widely used. We have a government SUDS policy and plan now. There are huge benefits, even from gravel, frankly. Just don't aerate it or oversize it. But I'm going to come to the correct solution in a minute. This is one of our student projects at council offices and parking area, all stored within this, saving them many thousands a year in surface drainage charges. This is another project. I didn't build this, but this is quite interesting because an error by the part of the water retailer in this area caused a billing rate of £7,500 a month for this 5-hectare site. That creates an interesting economic model, because if you consider that actually less than 10% of that site is water attenuation, £7,500 a month for what should we say, half an acre, something like that, is good money if you can get it. So we have seen a situation where water companies, for a variety of reasons, are failing to effectually drain the areas they're responsible for. We are seeing this huge upturn in public awareness of these issues. Certainly this school were enraged to get the bill because they understood really just how relatively cheap it is to store storm water. At £7,500 a month, they could have been building several of these systems a year. If they could do it, frankly, any landowner down the run of the sewer network from this area could and should be able to get into this competitive market. That's part of the legislation behind the privatization. Common carriage, as it's called, works perfectly well in electricity and telecoms. Water is just as easy to meter. Picture there of Bill Blake. Bill continues to be now a friend and a close advisor, part of Water21. For many years, he was the senior pollution control manager for Stroud. He's been retired now for a long time. But in the early 90s, a lot of the smaller sewage works, as a benefit of the privatization, came up for renewal. And at Evening, we had the problem that there were very low summer flows in the stream, and the majority of the flow in the stream was made up with treated effluent. And Bill understood about reed beds, and he imposed such a tight ammonia standard that a reed bed was the only way, a gravel reed bed, which has worked very well. It's almost impossible for there to be a pollution incident at this particular sewage works, or indeed any other with a tertiary polishing reed bed. Severn Trent built hundreds at smaller sites following this. I mentioned that I had a very positive relationship at a high level with Severn Trent, and by 2003, their understanding of the need to do something about storm surcharges from CSOs led them to asked me to draw up some plans for a pilot for putting reed beds on CSOs. Incredibly, party politics in Stroud prevented it happening. So it was backed by the MP, who was a different party to the council. We tried promoting it through a local water group, and that was led by another party. They wanted the sewers all relined, which has led now, as if you just keep passing the problem on downstream, eventually something's going to give. CSO discharges happen typically 100 times a year in Stroud now. There used to be over 50 CSOs. They were all rationalized down to a small handful. And if you reduce the number, you'll get quite a big variation in rainfall across a catchment like Stroud. But if you reduce the number of CSOs, then the frequency of discharge at any one or other is going to increase. So we now have a £25 million refurbishment going on. It saddens me. I think Severn Trent did their best in 2003, but we have colossal delays with our traffic now. It's a huge cost. My estimate in 2003 was that we could permanently resolve storm surcharges for less than £500,000 then, maybe less than £1 million now. And I believe that the new sewer enlargement will still feature overflows. I dug into some of my old references from many years ago. Forgive the poor quality of the graphic here. But one of the unique features of the Stroud sewerage network is the very high head differential, upwards of 200 meters head differential. We could actually run some hydropower off this, and we would have to use some of these great inline screening technologies that are coming out now. When we looked at doing this in 2003, these weren't available. We were just looking at disposable sacks to capture the trash. You don't want the trash going over the reed bed. This design of reed bed, a vertical flow reed bed with a swale. Just at the moment, I'm working on a very high profile project. I won't name it. It was a project that was put in 30 years ago. It's coming up now for refurbishment. In the last 30 years, its population that it's treating has gone up 400% over the original design criteria. The reed bed's failing, but the swale, which in this case is planted with willows, is working just fine. We have a few 100-year-old withy beds or willow wetlands working on sewage dewatering still to this day in Gloucestershire. This was another student scheme, 95. This was an unsewered village when we did the scheme. The village asked us to look at this solution. So a combination of reed beds and biomass plantation. It turned out with an additional 60 acres of biomass, which would have taken the sludge from the septic tank, we could have produced 100% of the village's potential domestic energy for just £25,000. They ended up with a pumping station, of course. Now, I said that gravel reed beds were not really the solution. A few years after my great realization that the gravel approach was not the best way, I was dragged kicking and screaming by a friend up to Billingham to see a proper reed bed. And reed bed had been built by Dr. Lucian Gill. And you can see his picture there, and I think he's joining us tonight. So he may want to step into the Q&A, and James, if you let him, I'd appreciate it. So those three gentlemen on the top left are standing in front of a triple SI, actually. It comprises 7 football fields worth of reed beds that Lucian put in over 30 years ago. using his soil-based method, which he introduced to the British government in 1984, but for a variety of reasons wasn't taken forward. Frankly, horrendous. I'm not going to go into the reasons why now. Suffice to say that Lucian has built hundreds of these systems around the world, including, I believe, most of the world's largest, certainly the largest in the UK. In the case of the ICI scheme, highly variable chemistry, 3,000 cubic meters a day. The day it was producing, ironically, agrochemicals at colossal pollution loadings to some 99% reduction in the toxins. And significantly, after 30 years of operation, it's still working, but it's in the hands now of a waste contractor. They're called Scots. It sequestrated 17,000 tons of carbon, basically as peat. So we could be doing this on all the tertiary polishing and storm overflow reed beds on the municipal infrastructure. And it's designed, if you get the hydraulic gradients correct, these will have at least a 100-year lifetime. And as we have with the wetlands, albeit an inferior standard of treatment to Lucian's reed beds. This is a Canadian system for, I think it's 1,800 people, soil-based, of course. Typical performance of Lucian's soil reed beds, the upper 90s of reduction of the pollutants. Phosphorus, which is a major issue. I mean, he introduced it to the appropriate government agency in 1984, 99.6% reduction in phosphorus. Here's Lucian's extraordinary work in Africa, working in the Sudan at 9 locations. Lucian having a talk with a local poacher, who I think then turned into the bailiff of the lake where the fish appeared after only a few years. This is basically what we were demonstrating at the local scheme. I showed you a few slides back, a biomass plantation, pre-treated with reed beds, and then the lake. This is early on in its operation. The lake filled very quickly, of course. Sadly, Sudan suffers regular warfare and civil disruption. So whilst the systems are still working and incidentally providing water for millions of people from heavily contaminated oil waste with no traces of hydrocarbons, the wider scheme that he had in mind for a post-oil economy based on plants hasn't been fulfilled. Better start to move on. I think I'm probably running out of time, but just a few more slides to go. These systems at 2 square kilometers or thereabouts have an effect on the local climate. This is some of the monitoring of that. They have prolific biodiversity. These are the animals actually in the treatment areas, except for the small deer, which is in a pen pending its release. All the rest of these animals volunteered, they just turned up. So it's a shame that people of Stroud didn't want pelicans and other exotic wildlife in their valley. I jest, of course, but just like ICI, Billingham, a wetland can be prolific for biodiversity. The treatment is all subsurface, so it's perfectly safe. So I mentioned those 5 new DEFRA principles. We have yet to see them applied. You can see them laid out there. Frankly, the sooner we have the end of farm subsidies, the better, because they have clearly just funded bad practices, I'm afraid. We've got an animal sentience bill now, and as an Environment Agency catchment manager said to me a few years back, the super tanker is slow to turn. Well, the super tanker is turning. I'm very excited at the possibility that we're actually now largely through the economic problems, but also this wider awareness, moving from a flush and forget society to one based on care and diligence, where best least cost solutions can be applied to the greater benefit of us all and the environment. Thank you very much.
Thank you very much, Julian. Appreciate that very, very much. We've had a few questions through the meeting chat. I will ask away. So the first one's from Will Hooper. Have you come across much research or study into heavy metals or oils running off from highways into rivers?
Yes, I have. This is an area that Lucian Gill is probably the world's expert on. Certainly hydrocarbons are very much his area, and he's done a lot of work. I'll let him come on if he wants, or I would urge you to get Lucian along to give you a full session like tonight, because the full story of his work certainly includes what you're asking, Will, and much more besides. Sounds like Lucian's joining us.
Yeah, I mean, the question before, we were going to convert a section of the system that we built for British Steel, which for the South Wales motorway, to take all of the, I think it was 17,000 meters cubed in a storm flow incident. If the motorway had gone ahead, it was cancelled, but we did all the study. And we had an existing system in the steelworks that had been doing PAHs, oils and ammonia and everything, which would have taken it fairly easily. Metals is a different chemistry, but we've done lots and lots of metal chemistry. It's more complicated because, of course, organics you can destroy, metals and phosphorus you accumulate, but it can be done. It's a simple answer.
Perfect. Thank you very much, Lucian. A question from Talia. How and who would undertake the inline sewer screen system?
Well, the implementation of screening within a sewer network comes up when the sewer is refurbished. If you're going to go down the route of putting a wetland on the CSO, you would need such a facility. I think the same technology can be used to separate out clean enough water on some very steep sewer runs to run a hydro turbine as well. Scottish Water are doing amazing things, and certainly I've looked at a few sites for them that have come close to this. That's on treated sewage so far. But yeah, I quoted the technology from Amiblu. I believe there are other companies supplying these screening systems.
Brilliant. I've got a quick question, and hopefully it's not too contentious, but avoiding the politics of Brexit, do you believe that based on the proposal to pay farmers to protect the environment, there are grounds to be optimistic at all, and that soil management will improve?
I have my doubts. The transformation in farming required is colossal. It's a huge change in culture. I mean, actually, we need to get to a position, if you follow through on those 5 new principles from DEFRA, that the polluter pays, we will ultimately be prosecuting those farmers who allow their soil to degrade and runoff to issue from their land. So we, as so many things in our society and economy, at the moment, we've got it completely back to front and inside out. And we've heard in the last month or two that 90% of the carbon credit schemes that we all thought were making our airline trips that little bit more sustainable don't even work. So yeah, we need a huge transformation, but we can see where we need to be. And there are good exemplars out there, like that small farm I showed you in Stroud. I'll curtail it there because I'm political.
I did wonder whether I should ask the question, but it's quite interesting. Another question from Matt Wright Anderson. What happens to the reeds at the end of their design life? You mentioned high removal rates of contaminants, which presumably makes it quite difficult to deal with.
Well, no, as Lucian just said, the organics are very substantially destroyed over time in a correctly built reed bed. So this means, you know, after 20, 30, probably more years, after decades, you can basically take this material out as peat. I wouldn't recommend putting it on your flower beds or certainly your vegetable patch, but it would be fine to go on a biomass plantation, which would then be the next stage of remediation.
And we've had one final question again from Talia on the subject of the reed beds, but how do they cope in relation to microplastics and pharmaceuticals?
So it's a very important question. In terms of pharmaceuticals, they are dealt with by the reed bed. In terms of microplastics, there's a whole range of sizes with plastics. One of the benefits of the hydro turbines that we sell, well, two benefits actually. If you have a hydro turbine on the river and you have to have an intake screen and you need a device to clean that screen, so you can capture all those macroplastics, 90% of which in our oceans has issued from rivers. Microplastics are a different matter. Of course, any plastics going through a turbine are going to be broken up. Well, that's fine if that's then going on into a reed bed, because there are microbiologists that will deal with microscopic plastic particulates over time. But larger particulates are an issue, and you would have to settle them out.
That's great. Thank you very much, Julian. We haven't had any more questions through the chat. So I think we will end it there for tonight. I would like to thank you on behalf of the ICE for presenting tonight. I found it exceptionally interesting. And I appreciate your time and Lucian's on the matters.